Okay, so welcome everybody. Hope you're all enjoying NDSML. My name is Alicia Montoya. I work at the Swiss Re Institute, which is the R&D arm of Swiss Re. Now, Swiss Re is one of the leading reinsurers in the world. And today I'm here with my colleague Elena Pizzica, who is a supply chain and machine learning expert. And we are here to talk to you about quantum cities, which is a data-centric approach to sustainable cities. And specifically, we will focus on how we can use machine learning in order to bring supply chain resilience. So let's go to the next slide. So everybody talks about the new normal. And I have to tell you, working in a risk company, there is no new normal. The only thing that's normal is that everything keeps changing. So we're now calling this the dynamically changing normal. And the other thing that we're seeing is that catastrophes over the last couple of years are crippling our economies and societies. And everybody's followed all of these, and I'm sure none of these are any news to you. I think what might be news is that despite the fact that Swiss Re and governments and other financial organizations have plans for during these catastrophes, they're becoming bigger and bigger, and they're interconnecting and creating risks that nobody can cover. And so, and that's on a financial level. On a human level, the scale of loss is, something nobody wants. And so it's really important that we use technology and machine learning in order to shift our industry from what has traditionally been paying for risks after the loss to really developing better models in order to predict and prevent risks as much as possible, and then help us manage risks during the event, and then bounce back after the event. And so if we go to the next slide, you can see this shift in the insurance industry from a product perspective, from an after event product perspective, to a before, during, and after resilience focus. And it's of course, I like to say that prevention is the best cover, because everybody prefers to avoid the risk in the first place. And if you can avoid the risk, at least minimize the impact by reacting faster and more effectively. So if we go to the next slide. Now, why cities? Well, by 2050, the UN predicts that 70% of people will live in cities and 80% of our assets. And so cities are a critical focus area for Swiss Re, because we are seeing increasing losses in cities. And this is due to several aspects. One of it is just the sheer density of cities. So some of these mega cities are more than 10 million population in very small environments. And so the interconnectivity of risks is very high. And so this is part of what we try to model with quantum cities, is understanding those interconnections and then being able to provide solutions for these interconnected risks. So if we go to the next slide. Now, in theory, we have great frameworks where we think through very systematically what are the risks, how are they connected, and how can we address them. The reality is that these risks have multiple levels of connectivity, and increasingly so as our economies, on the one hand, increase in density, but also in connectivity and digitization. And the other difficulty is that we're building on existing systems. I always, I lived in London for a while, and people always criticize the tube. But of course, if we designed the tube from scratch today, we would probably come to a very different design. But think about the tube. I mean, this thing has been going for, over 100 years, and you can't just stop London, and you have to adapt based on existing platforms and processes. And this is the difficulty that we find today, is a lot of existing systems, and then all these new technologies that we want to integrate, but there are all kinds of difficulties. So if we go to the next slide. And so what we're here to discuss today is how can we tackle these interconnected risks by using data-driven machine intelligence enhanced solutions. And my colleague Elena will give you very concrete examples of how we're doing that for insurance and the risk space. Next slide. So Quantum Cities looks at the interconnectedness of risks. And specifically, we called it quantum because it looks at the underlying entanglement inherent in urban digital economies and societies. And what we do is, rather than look at risks individually, which is typically what insurers do, we look at them in terms of their interconnectivity and entanglement, and thus the term quantum cities. And then we work with partners and companies throughout the world in order to develop solutions to provide this 360-degree protection. Next slide. Now, we talked a little bit about Beirut at the beginning. We don't have full numbers for Beirut yet, but I wanted to share with you a similar example which happened in Tianjin. And you know, the sad thing is that so in Tianjin in 2015, there were two massive explosions in the port of Tianjin that caused billions in losses and you know, human injuries, and it was a very tragic event. It caused 173 human victims, tons of losses, and the mess that ensued took months and months to resolve because all of these risks were disconnected. There were all kinds of different insurance coverages that covered partially, and there was no holistic risk management. And so specifically what happened is there were very dangerous chemicals sitting very near import vehicles that were very expensive. And so what happened was when the chemicals caught fire, they damaged everything around them. And that included these very expensive import vehicles, as well as some nearby warehouses and containers. And so this is how it propagated very quickly and caused enormous losses. And so sadly, when we lived through this in Tianjin, we thought, never again. What can we do as an industry to make sure that this never happens again? And of course, I have great hope that we will one day invest enough in the technical infrastructure as well as in the data integration and data engineering required to then have that holistic risk in ports so that we can avoid things like Tianjin. Sadly, I was proven wrong last year with Beirut, where it happened, very similar circumstances. And so ports are a key focus for us, and of course, so are supply chains. Next slide. And so what we look to do here with Quantum Cities, specifically in the supply chain and transportation area, is to develop a 3D view of risk in high resolution, understanding the interconnectivities and being able to predict how these risks can propagate across space, time, and the economy. Next slide. And so we work with, once we understand the risks better, we then work with partners to develop risk solutions. And those partners may be companies and they may be governments. And what we're trying to do is to try and solve for the risks that you see in the 4 buckets and their interconnectivity. Because as we've learned, you cannot solve for natural catastrophes without looking at supply chains or without looking at green infrastructure and how this affects human beings and their health. And so we look at these 4 in their interconnectivity. And today we will focus specifically on logistics and supply chain. And with this, I hand over to my colleague, Elena.
Thank you so much, Alicia, for setting up the scene. And it's really great to be here, meet you all, even if just virtually, but let's hope that next year will be again, do meetings like this in person. Okay, perfect. So my name is Elena Pizzica. I work in Alicia's team at the Swiss Re Institute, and I'm leading the Sustainable Supply Chain initiatives. And before joining Swiss Re, I was a PhD student working on machine learning techniques for big data and concerning also the bias in this big data. So as Alicia mentioned before, we are using, testing, and develop new machine learning techniques and new technology in order to solve some of the main challenges that we as Swiss Re and also our clients are facing in the supply chain framework. In order to leverage our risk insights with the increasing availability of data, analytics, and develop a forward-looking model in order to support this transition from prediction to prevention, as Alicia said before. Okay. So, I mean, sorry? Okay. As we all know, with this increased availability of data, we are able to monitor in real time, basically, almost every piece of the supply chain network. And so also monitor all the possible risk that can impact our supply chain and our client supply chain. And again, these risks are all interconnected together. So it's not possible to have, let's say, a vertical view, so just focusing on a specific risk, but we really need to have this horizontal and, if you want, also holistic view on all the possible risk, and develop some models that bring together all this information, and in order to have this forward-looking and holistic model to increase, first of all, the risk awareness, so the risk exposure, and then also improve the resilience of the supply chain. So we try to summarize, let's say, in 3 pillars, what we think are the main challenges in this context. And clearly, it's was not so easy, but we try to do our best. And again, here we have these 3 pillars, but all the pillars are connected together. So without one of the pillars, we cannot do much also for the others. So the first one is regarding data. And as a statistician, I strongly believe that data is the new oil. But I also know that having access to big data doesn't mean to actually have access to good quality data. And probably many of you will know how much effort and time and we need to usually source, ingest, and curate this data. And usually this is very time consuming. And so we are trying, I will go through this, some of the potential solution in the next slide. But so we have identified, let's say, this pillar related to data, basically. The second one is about modeling. And again, we said that we need to focus on multiple risk layers on multiple things, and we need to have this forward-looking model to get more accurate risk insights, for example, and also limit the impact of possible business interruption. And I would say last but not least, the third pillar is about, I would like to call people and sharing data and knowledge. This because, for example, the idea is how to use technology to increase the willingness in sharing data, but also models, idea, and and results, using a trusted environment, preserving the privacy, and also ensuring full transparency on the whole value chain. Yeah. So first pillar. We said that we spend a lot of time in source, integrate, ingest, and curate data from multiple sources. And these multiple sources can be internal data, in our case, Swiss Re data, risk insights, and analytics, can be data from clients, and can also be third parties data sources, both from commercial data providers or public available data. And as you know, I mean, the data are not usually with the same type. So we also may have different type of data from satellite images, from raw data, text data, and so on. So we can really think about combining all these pieces together. Yeah, for example, we estimate that in our industry, so in the insurance industry, we spend almost the 70% of the time, of a project time in this process. So this, is not very good, I would say. And also sometimes, so we do a lot of, we spend a lot of time on this, but when we onboard, for example, a new client, we need to start again from zero, so from scratch, because we don't have at least we didn't have a full replicable process when onboarding clients, for example. So one of the possible solutions is to use cloud-based warehouse. That basically the idea is to directly ingest raw data from several sources and then transform this data as needed, but only in the second phase, instead of the other way around. And this is very, is less time consuming, clearly, but also having, let's say, common data catalog based on industry standards can be very helpful when we have to search and match different data sets that basically can also have the same information, but just with different names and so on. And this can be very helpful. And for example, on the right-hand side, you can see one example of how we match different data sets regarding suppliers' location. And we use some text analytics algorithms and also the geodata corresponding to this supplier to understand if two suppliers were actually the same, even if the name was not exactly written in the same way. So for example, the first two suppliers are actually the same, while the third one on the right is another supplier. Yeah, so I mean, having this is very helpful, because having this type of replicable and common data model is super helpful in order to not spend so much time when onboarding new clients, and so save times for the second pillar. That clearly is the one that any data scientists love the most. That is the modeling one. And my opinion is that it also, from a business perspective, is also the one that generates the most value, because it's really related on the modeling and and creating value in this case. But clearly, I mean, as I said before, without curated data, we cannot get any accurate results. It's like cooking. If you don't use the right ingredients, you clearly don't get any, at the end of the day, maybe you don't even eat, because you cook something very terrible. So in our context, the data are really the key ingredients for the modeling. Before the modeling itself, let's say, there is the major pain points for our clients. That is actually having full visibility of the supply chain. So and not only, let's say, on a machine, on a computer, but they really want to see and visualize the whole network, because for them it makes it very tangible. And in general, I think that you all know that how important also the visualization part is really helpful also to explain some modeling. So in order to reconstruct the whole network, the supply chain, we use some graph database techniques. So you can see one example in the right-hand side of the slide. And only after the reconstruction of the whole network, then we overlay some physical risk, for example, related to natural catastrophe, can be, let's say, also political risk, sustainability, and so on. So imagine all type of risk and possible business interruption event that might impact to the supply chain. And so considering all these risk layers and having this holistic approach, we can start first of all to understand, for example, the risk exposure of our clients, let's say, supply chain. For example, we can see if there are some, let's say, some suppliers. So, for example, our suppliers, our clients needs a particular product, and all the suppliers of this product maybe are located in a high risk region for some natural catastrophe. And clearly this is a problem. So this is only possible to see if we overlay all this structure. And and the second piece, so after the awareness, we can also try to assess and quantify the resilience of the supply chain, performing some scenario simulation, or what we call the what-if analysis, really to understand the resilience of the supply chain, and again, support this transition from prediction to prevention, or we call it also resilience as a service. So this is the, let's say, the modeling pillar. And okay, we said data are super important, models are super important, but clearly if no one wants to share their data and their results, it's like working just by yourself and not sharing knowledge. And again, I mean, we said, and Alicia said previously very, very well, that we need to think now about global supply chain. So we cannot think about, a very small supply chain itself. And if we talk about global, we need to consider that in the supply chain, many stakeholders, many players are involved, and all brings a lot of capabilities, a lot of knowledge, a lot of data for each particular piece of the whole value chain. And the risks are so interconnected. So, I mean, we really need, let's say, the help of people, the help of everyone. But again, we need to use the technology in order to increase this trustness and willingness in sharing data. And to do so, at Swiss Re Institute, we are testing some computational computing methodologies in order to preserve the privacy. For example, the homomorphic encryption and working in a trusted execution environment. So basically, we are testing this technology, and the idea is that we can, so everyone can decide to who, how, and what disclose to the other. But even if they decide to, not disclose for example, a data set or some models, the others can still models the encrypted information. So this is very, let's say, very, very helpful, not only for our clients, but also for us as Swiss Re, because we increase the transparency, because in that case we have full transparency on the whole process, and also because we can really leverage all the knowledge and all the insights from different stakeholders. And again, and this is super helpful for this transition also to more sustainable and resilient supply chain. And I think that I can hand over again to Alicia for the final summary.
Thanks, Elena. So hopefully we've given you a little bit of a taster of what life in a risk company looks like, and what the advantages of using machine learning in order to, first of all, acquire the right data and deliver it in a timely way to the right team, so as to really reap the benefits across the company, and also to look at risks in their interconnected way. And of course, when we look at cities, the complexity of bringing all this data together and being able to do some of this integrated modeling, like Elena described with hybrid modeling, so that we can start bringing all of these risk layers together and understanding how they interact and propagate in real time. It's a really exciting area. And definitely we are grateful for all the data scientists like you developing these new technologies in order to help us better understand risks and power our Quantum Cities R&D program. So we're open for questions now. Don't be shy.
Yeah. Let's see, I cannot see anything for the moment.
No, me neither. I could ask you questions.
Yes, please.
Yeah, why not? So you mentioned that the joy of most data scientists is actually on the modeling, and it's just quite surprising to me how much time we we spend on the data, and this is something that we'll be discussing in the panel just after this, which is where do you see the biggest obstacles when it comes to automating some of the processes, or where do you see the biggest opportunities in automation so you can focus more on the modeling part?
Yeah, so I will, maybe this is let's say an answer, and I will be a bit biased on this. So basically, just a fun fact is that the first day of my university, my statistician professor said, okay, you will spend most of the time on, curating data. And actually, it is true. And this because also the increasing of big data. So usually big data is not collected, let's say, sometimes for a specific scope. So it's just collected and that's it. So usually, let's say, for example, in design of experiment, that is a really branch of statistics, we collect data from a specific scope, so that also for the modeling part is even easier to then model this and get the results. So the main challenges for me is really the idea that if now people start collaborating together and use all the data that we already have in a more curated way, and from the designing thinking, so not just collecting all the data, but really think what is the best way to collect this kind of data. This will also help a lot for the automation and also for the modeling phase itself. So this for me, let's say, is the main challenges. But I think that we are, we don't talk more on, let's say, big data, but I think that from maybe like 2 or 3 years ago, when the modeling phase was really on the top of the pressure, let's say, now we think more about data itself and not only on models. So this is super cool.
Yeah, and I think that's so important, right? Because the amount of data, if we don't start getting really smart about what data, I guess before the problem was just getting any data, and now it's getting the right data. So that and things like edge computing also hold great promise, because of course if we can do some of the compute on the edge, then that helps us also simplify our processes. Hey, I'm just seeing a question from Christopher asking us, did you integrate any machine learning in the analysis of the graph, or was that done with traditional mathematical modeling?
I would say the first phase clearly was done with traditional mathematical modeling, but the idea is really, because it was just the first step into that specific project. But the idea is that we start with a bottom-up approach, so we start simple to see if all the assumptions are correct and test it also with clients. And I strongly believe also that starting with simple things, it's very, very helpful when discussing with clients. But then, I mean, clearly the idea will be to integrate, let's say, the new technology and really the latest, the really new machine learning algorithms and so on, also for that. So as Alicia said, we are in R&D, and this is really the main idea. So we keep learning, we continue to improve our model, ourselves, and yeah, and hopefully the world, in this case.
Absolutely. We have another question from Christine. So great presentation. Thanks for sharing. Thanks, Christine. How do you prevent to reinforce biases and thereby jeopardize economic opportunities in high-risk areas? Good question. Yeah. Do you want me to take it?
Yeah, please.
I mean, I think there are two levels to that, and one is on actually understanding. So I think on the modeling side, just understanding how these risks interconnect and what the impacts are. So we have risk experts across all these different industries that we cover, and we work very hard to bring these models together, and that is and avoiding biases is one of the key considerations that we have, because otherwise, the framing of the problem is the first problem, and then building the models and using machine learning to then not exacerbate biases is the second level. But I think before that, just understanding the risks is really critical. So we like to say garbage in, garbage out. If we don't frame the problem correctly, then the bias is inherent, right? And so the first very important aspect is to actually have the risk knowledge and then build that into the models and work across these different disciplines in order to understand how they work together.
Yeah, I mean, it's also, if you think about the, sharing knowledge and so on, having this type of heterogeneity for the supply chain framework is also helping to, avoid this type of bias, because you have different perspectives. So it's not just, an insurance company that said this is the right way to proceed, but it's more on a collaborative, environment, I would say. So also this, I think that is super helpful in order to, again, find the right data and so on.
Fabulous. And that doesn't mean that we always get it right, by the way. So I think we're really good at known risks that follow a kind of linear path. So we're very good at things like a natural catastrophe risk that we've been modeling for many years. Some of those risks are now changing due to things like urbanization and climate change, and so there we see discrepancies. But normally we're risks that we know and we have past data for, we're more comfortable with. When it comes to new risks, and whether they come from regulatory shifts or economic situations or social changes, like the propensity to litigate, we struggle until we get the right perspective. So Elena is absolutely right. We work with partners to get those different perspectives in order to build those into the models. So we start with a rough model and then we perfect it. Okay, if there aren't any more questions, we're going to shift over to the panel and hopefully we'll see you there. Thank you so much.
Thank you so much.